today we'll be going to discuss that what is actually law of conservation of mass. Okay, so we have discussed this one in the previous classes. So today we're going to discuss law law of multiple proportion. Sorry, law of constant proportion, and it is an important. We can say that it is an important law. So that I'm going to explain you this one more time. So the problem related to this one, you will be able to solve this one. Okay, okay, understood everybody? Understood?
Yes,
Yes.
sir.
Okay. So what is law of constant proportion? We can say that uh, law of constant means that there's something constant we are talking about. So what does it say? That in a chemical compound, in a chemical chemical compounds, elements are combined in a fixed ratio by mass. Okay. So let me explain you here. You have to memorize the mass of some important elements, and it is very important. So I'm just writing the mass of some important element here, and you have to memorize and note it down. Okay, because this we need to study at least, and we have to memorize this one. So just writing, hydrogen is going to have mass. It is the element here. This is element. This is symbol, and this is the molecular mass. Molecular, okay, or atomic mass. This atomic mass. Okay, so if I'm talking about H is, sorry, hydrogen. Hydrogen is an element, but its symbol is H, and its atomic mass is, if I'm writing here, the molecular mass. So molecular mass. Okay, so if I'm just talking about, this is hydrogen, symbol as hydrogen. Okay, so its atomic mass is 1. Okay, but if I'm writing hydrogen gas, so hydrogen gas exists in the form of H2. So we have to write here H2. So now this is not this H2 is not an atom, it is a molecule. So the molecular mass of H2 is 2, because there are 2 hydrogen atoms. Okay,
Yeah.
got it? If I'm talking
Yes,
about,
sir.
that is carbon. Carbon is going to have C mass, and this is the atomic mass is 12. Okay, and another one is that I'm having nitrogen. So we have nitrogen, and the mass of nitrogen is N, and its mass is actually 14. But if I have nitrogen gas, then it is N2, and its mass will be, now it become molecule, and it will going to have 28 mass. 14 into 2, 28. Okay. Similarly, oxygen is going to have, oxygen is an element. If it is acting as an element, it is O. It is going to have mass O. But if I'm talking about oxygen gas, then it exists in O2, and this is going to have 32 mass. Okay, note everybody, note it down, everybody. When you're done, please let me know. Okay,
Done, sir.
everybody done?
Yes, sir, yes.
Okay, so if I'm talking about, the next one is this is O, this is oxygen gas. If I'm talking about nitrogen we have done. Next one is sodium. The symbol is Na, and it is going to have atomic mass, that is 23. Okay, and then another is chlorine, that is Cl, and it is going to have mass, atomic mass, and the molecular mass here, molecular mass. So if it is Cl only, then it is 35.5. And if I'm talking about chlorine gas, then it will exist in the form of Cl2. Then 35 into 35.5 into 2, you will get 71. Okay, got it? Got it?
Yes, sir.
And most commonly asked is magnesium. Magnesium is Mg, and it is magnesium. Magnesium is Mg, and it is going to have mass 24. Okay. Aluminium is Al, and it is going to
So
have mass 20.
magnesium has 24 electrons in the orbit.
No, it has 12. The atomic number of magnesium is 12, but its atomic mass is 24. Okay. So we'll
Okay.
discuss this one. Okay. So this is aluminium that is going to have 27 mass. Okay. Got it? Got it. Nitrogen, oxygen, silver, lead, calcium. Calcium is going to have 40 mass, Ca. Calcium is Ca, and it is going to have 40 atomic mass. Okay. The other are important. These are the important ones that we need to memorize. The other one, the mass should be given to you. Okay. And if I remind you, so please left some space here. Okay. Leave some space here. Okay. So let's move further, dear students. Have you noted this one? Everybody in the class?
Yes.
So just a minute.
Yes, sir, noted.
Yeah, done, sir.
Done. Okay, so let's move further. Right. Now, what does this law of conservation of mass say? Law of constant proportion. Constant proportion. I have written this one previously. And what does it say? It says that when in a chemical compounds, elements combine together in a fixed ratio by mass. Okay. So if I'm having this hydrogen atom and this when react with oxygen, this will gives you what? This will gives you what? H2O.
Water.
Water. And when you balance this one, you see that here in the law of conservation of mass can neither be created nor destroyed. So check in your
Yeah.
copy what is the mass of hydrogen atom? Hydrogen gas H2. Check in your copy. What is the mass of H2? We have written this one. 2 gram, 2. And mass of O2 is 32 that we have written. You can check it. Then the mass of
Yeah.
water would be
34.
not 34. It is the mass here. If we have this is 2
Oh,
for hydrogen,
okay,
H2, and
yeah.
16 for this one. This is 18. So you see here that is total mass is 34, but here this is 18. So it is not. It is violating the law of conservation of mass.
Yeah.
So for this we need to balance this one.
Yes.
We need to balance this one. So we can balance this one. We will learn this how to balance, but you know that this is the 4 hydrogen atoms, and this is also 4. Now oxygen was unbalanced, so I just put here 2 to balance the oxygen because here is only 1 oxygen, so I just multiplied by 2.
Yeah.
So on multiplying this one, this is not only going to multiply with oxygen, this is also going to multiply with hydrogen also. Now this hydrogen has become 4, so I just
But
multiply this one.
H2 is it's balanced. It should be balanced because it already exists in nature, right?
Nature means what do you mean? Nature does not mean let me explain you here that it should be the total mass should be balanced. The total mass of the reactant and product must be balanced.
Yeah.
So if I'm having this one here if I'm having this one only 2 and this one having 32, this should be 34, but the mass is 18 only. One molecule of water is going to have 18 mass. So this is not balanced. So we need to balance this one. So you see that here this 2 oxygen atom, here is only 1 oxygen atom. So in order to balance this oxygen, so there are 2. So we have to multiply here by 2. So this 2 is not only multiplying with oxygen, this 2 is also multiplying with hydrogen also. Okay. You understood?
Okay, sir. Yeah.
Now if I'm going to multiply this one by 2, so this one by 2, so this has become 2. Now it is balanced. But now you when you write here 2, so this 2 is not only multiplying with this oxygen, this 2 is also multiplying with this hydrogen also. Okay. Now 2 into 2, so this will become 4 hydrogen atoms. Everybody understood this? And so we have to multiply this one also by 2. Now this has also become 4. Now this reaction is balanced. This reaction is balanced. Okay, this reaction is balanced. Now you see here the total. Now there are 4 hydrogen atom, 2 to the 4, 4 hydrogen atom, and 1 hydrogen atom consists of 1 mass. I have written that H is equals to 1. Or you can say that H2 is equals to 2. So they are 2 H2 molecules. 2 H2. So you have to multiply it by 2 because you have to. So this is 4 gram, 4. And this one is, what is this? This is 32 still. And this is water. One water molecule H2 has mass 18. We have calculated 2 plus 16. That is 18. So one is going to have 18. So 2 such molecules of water is going to have 36 mass, or we can write it 2 times of 18, that is 36. Now this is now following the law of conservation of mass.
Yes, sir.
So if I write it as one H2 plus O2, 2H2 plus O2 will gives you 2H2O. So here we write here that for every 4 gram of hydrogen react with 32 grams of oxygen to gives how much? 18 grams of, sorry, 36 grams of water. So if it is not necessary that we are going to have this number every time, what we need to do is we have to cut this one, because this is already multiplied with 4. So we can bring this one in the simple ratio. We can write it 1 gram react with 8 grams of water, 1 grams of hydrogen react with 8 grams of oxygen to gives 9 grams of water. Okay. This is the simplest ratio. When water is formed, the simplest ratio is 1:8:9. Okay. Got it? Got it?
Yes, sir. Got it.
Please copy this one, then I'm going to give you the next equation.
Sir, I have to note this down as well, right?
Yes, this
I
one
have
also.
to, yeah,
Sir,
okay.
finish noting.
Everyone noted?
So 1 second. Done, sir.
Done, everybody? Okay. So I'm just writing here N2 plus H2 will gives you NH3. With the help of this one, first balance this equation. First balance this equation. This is nitrogen gas. Nitrogen gas when react with hydrogen gas. Nitrogen gas when react with hydrogen gas. Hydrogen gas. It gives you ammonia. Ammonia. NH3. Okay. So first balance this equation and then find out the simplest ratio of nitrogen and hydrogen that they must react to form this ammonia gas. Please balance this equation. Done? Balanced?
1 second,
No,
sir.
sir.
Try to balance. Check how many nitrogen atoms are here, how many nitrogen atoms are here.
Done, sir.
So what is it?
Sir, N2 plus 3 H2 and the product 2NH3.
N2 plus 3H2 will give you 2NH3.
3H2 and 2NH by 3. Yeah,
Okay,
3.
okay. So you have seen here that this one is nitrogen. One nitrogen atom is here, and this one is two nitrogen
Yeah.
atoms. So to balance this one, we have to multiply here by 2. Avni, you understood?
Yes,
You
sir.
understood?
Understood.
Okay. Now this nitrogen is multiplied with this 2, so it will become 2. But this hydrogen atoms are also going to multiply. This hydrogen atom is also going to multiply. Abdul Jabbar, are you getting this one? Turn on your camera. Okay. So if I'm having this is hydrogen, so this is multiplying with this one, you will get 6 hydrogen atoms. What will get? 6 total. 2 3s are 6. So we have to multiply this by
Yeah.
3 to become 6, and this one will remain as it is. Okay. Now you
Yes.
according to the law of conservation, I have written that you can check in your copy, that is 3H2 will gives you 2NH3. 2NH3. Let's calculate the simplest ratio of this one. Calculate the ratio, simplest ratio of this one. Calculate. What is the mass of N2? What is the mass of N2 that you have written in your copy? You can check it in your copy that I have written. Molecular mass of N2. Check it, Abdul Jabbar, tell me. Done? Tell me what is the problem here.
No, sir. I did it.
You did it. What is this? This is 28. You check it. You can check it. The mass of N2 is 28.
Yeah.
That we have written in your copy. There are 6
Yes.
hydrogen atoms. 2 3s are 6, and one hydrogen atom has 1 mass. So 6 hydrogen atom will have 1 into 6.
6. Yeah.
So
Yes,
total
sir.
6. So this is 6, and this is 1 NH3. Calculate the mass of 1 NH3. So NHH. 1 N has how many? 14. This one 1,
14.
this one 1, this one 1. This is total NH3. Okay. So 14 plus 1
Yes.
plus 1. You will get 14 plus 3. You will get 17. And that is 2
Yeah.
NH3. 2 NH3. So this is going, 1 is going to have
17
17.
into 2.
So you will multiply this one by 2. You will get 34. You understood? Everyone?
Yes, sir.
Avni? Abdul
Yes,
Jabbar?
sir. Understood.
Shumaisa?
Yes, sir. Yes, sir.
So this will be 34. Now the simplest ratio will be this one you cut it. And what you will get? What is the simplest ratio here? You can get it. You multiply it by 2. You will get 14:3:17. Okay. So this is the simplest ratio. 14:3:17. Okay. Got it? Got it?
Yes, sir.
Yes,
Got it.
sir. Yes,
Now,
sir.
if I'm having a question for you, that if you have a question is being given, calculate the mass of carbon dioxide form of carbon dioxide form. Okay, let's take the example of ammonia first. Calculate the mass of ammonia form. Ammonia form when 14 gram of 14 gram of nitrogen gas react with 10 gram of hydrogen. 10 gram of hydrogen. Okay, try to solve this one. Then I'm going to explain you. Calculate the mass of ammonia formed when 14 gram of nitrogen gas react with 10 gram of hydrogen. React with 10 gram of hydrogen gas.
Sir, done writing the question.
Done this one? Done? Okay, so have you solved that one? Or should I
No,
help
sir.
you? No. Okay, let me help you. Let me help you in this one. So here is a question. Okay, here is the question. Let's calculate the mass of ammonia found in 14 grams. So this is nitrogen. Nitrogen when react with hydrogen gas. Nitrogen gas when react with hydrogen gas. Hydrogen gas. So it will gives you ammonia. It will gives you what it will gives you?
Ammonia.
Ammonia. So do you think that if we are having 14 gram this one, okay, and this is hydrogen is 10 gram, so it should give you 24 gram ammonia? According to law of conservation of mass, do you think so?
Yes, sir.
No, it is incorrect. Actually, first you need to
Sir, is the hydrogen 20 or 10?
it is 10
Okay.
gram. So if this is the law of constant proportion. What does it say? That in a chemical compound, elements combine in a fixed ratio by mass. Okay. So for example, if I'm having this nitrogen, okay, and you have noticed this one, that for every nitrogen, you have written this N2 plus 3H2 gives you 2NH3. You have calculated this one. And you notice that this is a nitrogen is going to have, you balance this equation, you notice that this is 28. And the simplest ratio you have calculated here. The simplest ratio for nitrogen is 14:3:17. Okay. So what does it means? It means that for every 14 gram of nitrogen, only 3 gram of hydrogen is required and 17 gram of ammonia will be formed. Okay. This is fixed. For every 14
Okay,
kg,
sir.
if I'm taking 14 kg, then 3 kg of hydrogen will be required. And then 17 gram of ammonia is formed. So for every 14 grams, if I'm talking every 14 grams, only 3 grams will react out of 10 and 7 grams hydrogen will remain unreacted. Okay. Got it? So if we have 14 gram, this one, 14 gram nitrogen, then only from this one, this 10 gram, only 3 grams of hydrogen will react and 17 gram of ammonia will be formed. We will write, since the, okay, you can write it that, since the law of constant proportion said that elements in a compound combine together in a fixed ratio by mass. So for every 14 gram, only 3 grams of hydrogen will react, and the 7 gram out of 10 will remain unreacted. Okay, got it? You understood? Everyone in the class?
Yes, sir.
Rumaisa, Avni,
Yes, sir.
Abdul Jabbar, So if I'm having if I'm having this one, that is nitrogen when react with hydrogen gas, it forms ammonia. If I'm having 6 gram of hydrogen, then how many grams of nitrogen is being required to react completely with 6 gram of hydrogen?
6.
Only 6. So you have to, you know the notice, you know about this equation, that is N2 3H2 plus 7H3. You know that the simplest ratio is 14:3:17. So if I talk about that, if we have this 6 gram, for making this 6, you have to multiply this by 2. So you have to multiply this also by 2. And this also by 2. So if we have 3 gram, then we need 14 gram nitrogen. Okay, if we have 3 gram hydrogen, then for 3 gram, we need 14 gram nitrogen. Then if we have double of this one, then we will need 28 gram. Okay, if I'm having 9 gram, the 3 times of this one, then how many grams of nitrogen will be required? 14 3s are 42 gram. Okay, so that the simplest
Okay,
ratio
sir.
will still be 14:3. Okay, the simplest ratio is still 14:3. So every time you need to notice this one. So now I'm going to give you another question for the same. This is N2 plus 3H2. Then we'll solve the NCERT question. Okay, gives you 2NH3. And here it is that if I'm going to give you that the simplest ratio is 14:3:17. Okay, and now if you are having that 15 gram of hydrogen, then how many gram of nitrogen will be required to react completely with 15 grams of nitrogen? How many grams of this one will be required? Abdul Jabbar, tell me. If you have 15 gram of hydrogen, then how many grams of nitrogen gas will be required? Rumaisa, tell me.
Sir, can you repeat the question?
If we are having 15 grams of hydrogen, okay, the simplest ratio for reacting with nitrogen and hydrogen is this one, 14:3. For every 14 gram nitrogen, 3 grams of hydrogen is being required. Okay, you understood? Then
Yes, sir.
tell me, then if we have 15 grams of hydrogen, then how many grams of nitrogen will be required?
Sir, 26.
26. Why 26? You have 3 grams this one. Okay, and you need for every 3 gram we need 14. For
Yes,
6
sir.
gram, we need 28. For 9 gram
Yeah.
we need 42. For 12 gram we need 14 fours are.
Sir, 72.
Yes, we have to multiply. So you know that, no, not 72. For making this 15, you have to multiply this by 5.
Yeah.
Yes.
So you multiply this one
14
also
into
by
5
5.
as well.
You will get 70 gram.
Yeah.
Okay, now I'm just going to give you the another question.
Okay, sir.
This is C plus O2 will gives you CO2. Okay, calculate the simplest ratio of their combination. Calculate the simplest ratio of their combination of mass. This is balanced already. There is no need to balance this equation. This is already balanced CO2. With the help of mass that you have written in your table in your copy, solve this equation. Done?
So 1 second.
What's the mass of carbon that you have written in your copy?
Sir, 12.
And mass of O2?
32.
32. And this, the mass of CO2 will be?
44.
Yes, 44, correct?
Yeah.
It's 12 plus 32, you will get 44.
Yeah.
Now, by what number you should cut all these three terms? Is there any common number that you can divide it by all? By which you can divide it?
2, 2.
No, bigger than 2.
Or 4, 4, 4.
4 3s are,
4 is easier.
4
Yeah,
8s
4
are,
3s
and 4
are.
11.
Yeah.
So here the simplest is that for every 3 gram, 8 gram of oxygen
Yes.
will be required to make 11 gram of carbon
11
dioxide. Okay.
grams. Yeah.
So if you have then NCERT question here, let me figure out this question for you. Wait a minute, let me have this question. Okay. Here is your question on your screen. Question number 2. What should be the answer for this question? Tell me. Question number 2.
Sir, question number 2 of exercise, right?
Yes. This is visible on your screen, huh?
Yes, sir.
Question number 2. Abdul Jabbar, again you turn off your camera. Your father told me that you need to turn on your camera, okay? Then why are you turning it off again and again?
Sir, I don't know how to solve this one.
This is simple that we are doing. 3 gram of carbon burned in, 8 gram of oxygen gives 11 gram of carbon
Yeah.
dioxide. So what is the mass of carbon dioxide will be formed when 3 grams of carbon? Okay, so if I'm having this one, note it down. This is very simple. So if it
Yeah.
is 3 gram oxygen is given to you, this is 3 gram carbon. Okay, and now you have 50 gram of oxygen. So how much grams of carbon
Okay.
dioxide will be found? Very simple. So you this don't think that it will become 53. No. The maximum
Yeah.
amount of oxygen that is being required to react with 3 gram of carbon is just 8 gram. When
Yeah.
3 gram of oxygen, sorry, 3 gram of carbon, 3 gram of carbon will require only 8 gram of oxygen,
Yeah.
not 8.1 gram. Only 8, not 7.9 gram, only 8. Fix 8. Okay. Got it? And if you have 50, so what does it mean? You have extra.
Yeah.
So out of this 50, 8 will be consumed.
Yes. The rest
And
will
remaining
be.
42 gram will remain unreacted.
Yeah.
Reacted. And how much amount of this 50? Only 8 will be consumed. So, and how much grams
Yeah.
of carbon dioxide will go? 11 grams of carbon dioxide will be formed. And 42 gram of oxygen will remain unreacted because for this, there is no carbon.
But then, sir, what will happen to that oxygen?
This will remain unreacted in the container.
Okay.
It will not react. Okay, you understood?
Okay, sir.
Understood? Everyone, have you noted this question? Noted? So let me give you one more question here. Okay, if I'm going to have C plus O2 gives you CO2. And the simplest ratio is given, that is 3:8:11. 11. It is not necessary that is given, it may be in kg also, ratio. So if I'm having 22 gram, if I'm having 44 grams of carbon dioxide, that I'm having, not 44, that I'm having 99 gram of carbon dioxide, 99 gram of carbon dioxide. Then how much amount of carbon and oxygen will be required? If we have 99 gram of carbon dioxide to form, then
Yeah.
how much grams of carbon dioxide and oxygen will be required? Rumaisa, you are not answering any question.
1 second, sir. Sir, do we multiply 8 and like 3 and 8 ratio by 99?
No, by
No,
9.
9.
Yes, we have to multiply by 9. So if we are having
So
this one
3
by
into
9,
9 plus 8 into 9.
yes.
Okay.
So what you will get? You will get 3 times 27 grams of carbon will be required,
Yeah.
and 8 9s are 72 grams of this one will be required. When you add this one, you will get 99. Okay,
Yeah.
got
Okay.
it? You understood?
Yes,
Let me
sir.
have use now. Now you understood. I think so that you are getting this one. Let me have some other equation. It is simple. N2 if I'm having carbon when react with hydrogen, it will gives you C2, sorry. Let have a simple equation. If we have calcium oxide when burn this one with carbon dioxide is passed through this one, it will gives you calcium carbonate CaCO3. Okay, calculate the mass of these three first. Now it is balanced already because this is one calcium, one carbon, and 2 here and 1 oxygen CO3. That is balanced. Okay, this is balanced. So when calcium oxide react with calcium carbonate, calculate the mass of this one, and this one first with the help of the table, the mass that I have given to you, because this is also a part. And the molecular mass you need to calculate. Okay, so you will learn that how to measure the mass of this one or calculate the mass of this one. Okay. So what is the mass of calcium? Tell me that you have written in your copy. How much?
Calcium is
Check in your copy that we
40.
have. Yes, it is 40. What other
Yeah.
students are not responding? Rumaisa, Abdul Jabbar, another student. Why not responding? Avni, you also? What is the mass of oxygen that you have written in your copy? Single oxygen atom. Rumaisa, tell me.
16.
The total mass of CaO will be 56.
Yeah.
56. And you have calculated the mass of CO2. What was the mass of CO2 that you have calculated? One molecule.
44.
It's 44. Since it is balanced, because you add to this one, exactly to this one, so you will get
Yeah.
this one.
Yeah.
So since it is balanced, you can write it
CO3.
directly 100.
Yes.
Otherwise, you can calculate this one. 40 plus 12 plus O into 3, you will get 48. 16 into 3. One oxygen atom has 16 mass, so you multiply it by 3, you will get 40. So you will get this one. Okay. Got it? Got it? So what is the simplest ratio? You can divide it by all by 4. You will get 14, 11, and 25. Okay. This is the simplest ratio. Got it? So if I have 7 gram of this one, then how much amount of carbon dioxide and this will be formed? Tell me. If I'm having this 7 gram,
So I have to divide 11 by 2 as well.
Yes. So to make it 14, 7, you have to divide by 2.
Yeah.
You will get 7.
And then
So
25 by 2
this-
as well.
This will also divide by 2. You will get 5.5 gram. And this will get
Yeah.
12.5 gram. So don't think that the ratio cannot be in decimals. Okay.
Yeah.
Got it? We are not studying just the bookish language. You need to do something extra. Okay.
Yes, sir.
And Rumaisa, Avni, you understood?
Yes, sir.
Avni, are you there? Avni is not responding. Should I call her parents? Avni. Abdul Jabbar, are you there?
Yes, sir.
Yes. Avni, are you there? Okay. Next again, this is N2 plus 3H2 will gives you 2NH3. Okay. Again, you are having this 14 is to 3 is to 17 ratio that you have learned this one. So if I'm having this, I'm having 4.5 gram. If I'm having 4.5 gram, type of question that we ask on this one, at 4.5 grams of hydrogen, then how many grams of this one and this one will be required? This one will be formed and this one will be required. If you have only 4.5 grams of hydrogen gas. Four 4.5 can be written as 9 by 2. Tell me, Prashita. Rumaisa?
Or
Yes. Avni, are you there?
how
Yes,
can
sir, I'm
3
here.
be divided into 4.5?
Was asking question, but you were not answering me. So actually you require 4.5 now.
Yeah.
You need to multiply by a number so that it will become 4.5. So what is that number?
1.5.
So if you multiply it by 1.5, you will get 4.5.
No, 0.5, 0.5.
No. If you multiply 0.5, it will become 1.5. It's
Oh,
half of this. Okay. So multiply this, you know
okay.
that this one. Okay. Or you can learn it by making this one. You can write it 44.5 can be written as 45 by 10. Okay.
Yeah.
So you have 3 and this you need to make 45 by 10. Okay. So
Yes, sir. So
whatever
I
the
have to multiply. I have to
just
multiply 17 with 1.5 as well,
yes.
and
You have to
14 as well.
so you have to multiply this 1.5 so that it becomes 4.5 because this is 4.5. So this one you have to multiply by 1.5 and this one also you have to multiply by 1.5. So you will get this one when you multiply 14 complete and half, you will get 21. Okay, you will need when you multiply 1.5, it means that full of this one and half of this one. So full of 17 is 17 and half of 17 is 8.5. So add 17 plus 8.5. 17 plus 8.5, you will get 0.5 and 8, 5, 15, 1 carry, then 25, 25 point. So 25.5. Okay. Got it? Understood?
Yes, sir.
Understood everyone
Yes, sir.
in the
Got it.
class? Okay. So let's learn the Dalton atomic theory. Okay. Let's have the Dalton atomic theory. So what was the Dalton atomic theory says to us? So let me explain you this one. Now this type of question you can easily be able to solve this one. Okay. I hope so. So what's the Dalton atomic theory says that? Dalton was the first one who discovered the atom, and he said that atom is actually indivisible particles. When you keep on dividing the matter, so a stage will come the atom cannot, means a particle cannot be, or substance cannot be further divided, and he called it as atom. Okay, what he called it?
Okay, sir. Atom.
He called atom. But you know that atoms can be now divided according, but
Yeah.
this is not in the chemical reaction. This is the nuclear reactions. And we have the two types of reaction, chemical reaction and nuclear reactions. This law of conservation of mass is applicable for chemical reaction, but it is not applicable for nuclear reaction, because in nuclear reactions, mass is converted into energy. Okay, mass is converted into energy. So mass can be destroyed. It can be converted into energy, massless unit.
Yes, sir.
So, but nuclear reactions, in nuclear reaction, we can convert mass into energy. That was given by the Dalton atomic theory, that is E is equals to mc square, that you will not going to study in the higher classes. Okay. So now talking about this one Dalton atomic theory, so the postulate that we are studying here, this is applicable only for chemical reactions and not applicable for the nuclear reactions. Okay, got it? So what does it says that? It says that all matter is made up of tiny particle called atom. This is simple. Atoms are indivisible particle which cannot be created or destroyed in a chemical reaction. And this is correct. The teacher used to say that now we can divide this one. This is incorrect. No, we are talking about the nuclear chemical reaction. We are not talking about the nuclear reactions. If I talk about the nuclear reaction, then it is assumption that we cannot say that here law of conservation of mass is applicable. So if I ask you that which postulate of Dalton atomic theory says you prove the law of conservation of mass, this is the postulate that atoms can neither be created nor destroyed, because you can't create the atom, nor you can destroy the atom.
Yeah.
So it means the total mass
It
of the
can only
reactant
be
product.
converted into energy.
No, it cannot be. That is the law of conservation of energy. The mass can energy can neither be created nor destroyed, will be converted from one form to
No,
another form.
converted. Yeah.
No, we cannot. Yeah, it can be converted into energy. Mass can be converted into energy, but not in the chemical reaction. In the nuclear, not in the nuclear reaction, not in the chemical reaction. It can be converted into energy in nuclear reactions, where the atoms is broken down and energy is being released from this one. Okay, that you're going to study in the higher classes in modern physics. Okay, here we don't have this one. So this first rule is correct. Okay, and the second one, if I talk about this second one is also okay. So if the teacher asks you that which law of Dalton atomic theory proves the law of conservation of mass, so this is the first law and the first postulate. That second postulate, atom is indivisible. Atoms are indivisible particle which cannot be created nor destroyed for a chemical reaction. So the students used to write that it can be divided. No, it cannot be divided in chemical reactions. Okay, everyone understood? The second one is atoms of elements have identical mass and chemical properties. So this law is not applicable. Atoms of an elements have identical mass and chemical properties. So we can say that atoms of different elements, the same elements, can have different mass. For example, in case of isotopes, this is an incorrect one. We will discuss this one. Okay. But if I'm talking about carbon, so carbon has two types of atom. One with carbon 12, the mass of carbon 12 atom is having mass 12, and another one is 14. The mass is 40. Okay. So here these are the two identical atom of carbon, but they can have different mass. So here this one is same. This portion is correct, that they have the same elements, have the atoms of same elements. Atoms of an element or same element have identical mass. No, it is this one is going to have. The atoms of an element can have different masses, like in case of hydrogen, carbon, hydrogen also. Hydrogen have three types of isotopes. We're going to this one. Isotope means three types of atoms. One is with mass 1, with mass 2, and mass 3. But they all three have same chemical properties. They all three have same chemical properties. They may have different physical properties, like they may differ in boiling point, melting point, or some other, but chemical properties is same. Got it? Got it? And here atoms of different element have different mass. It is also different elements can have same mass. For example, this is the carbon atom that is going to have 14 mass, and this is the nitrogen atom that is also going to have 14 mass, that we have written. So the two different atoms of two different elements can have same masses. So this one is incorrect, but this one is different. They must, but the properties of carbon and nitrogen must be different. Okay, so note this one. Note all these 3 points first. Then we will write all the point as same. Then we will discuss that what is the error or what are the drawback of Dalton atomic theory. Okay, so we'll write them separately. Okay, and this one is same. The atoms combine a ratio of a small whole number to form compounds. So this prove the constant law of proportion, and relative kinds of atoms in are constant. So this one. So this will be asked in the examination that which postulate of Dalton theory support the law of constant proportion. So this postulate prove the law of constant proportion, and this may be asked that which postulate of Dalton theory support the law of conservation of mass. So this one. Note it down. Down. Please note all these points about the atomic theory. Are you writing, everybody? Shita,
Yes.
Avni, Ramaisa,
Yes, sir.
Yes, sir.
note it down.
Yes, sir. Writing.
Done?
Sir, still writing. Sir, done.
Abdul Jabbar noted. Maisa, Prishita.
Yes, sir.